In this video, we're going to cover some introductory trigonometry. This video is for those of you who are just starting out with trig who want to develop a stabler trig foundation. Let's begin. This is the Greek symbol theta, and this symbol can be used to represent unknown angles, similar to variables such as x, so just keep that in mind. Trigonometry is a branch of math that helps us understand how the sides of a triangle and its angles are related, and this is commonly done in trig. This is commonly done with right triangles. Throughout the video, I'll be using the word function a lot. Don't let this word intimidate you. You can think of a function as a machine, where if you give it a number and you tell it to do whatever you want it to do, it gives you a number back. That's pretty much all a function is. Now let's start off with the three main trig functions: sine, cosine, and tangent. These can be rewritten as sin, cos, and tan because mathematicians are lazy. Now let's talk about sohcahtoa. Sohcahtoa is a mnemonic designed to help us remember what the three trig functions do, so you should commit this to memory. Notice that the first letters in sohcahtoa are directly correlated with their trig functions. So, because there's an S, is correlated with sine. Ca, because there's a C, is correlated with cosine. And toa, because there's a T, is correlated with tangent. Now let's do an example problem. This is a 3, 4, 5 right triangle. Let's solve for sine of theta. What exactly is sine? Sine is just opposite over hypotenuse, or opposite divided by hypotenuse. Let's look at the right triangle. Opposite of theta, the side opposite of theta, is 4. The hypotenuse of the triangle is 5. So sine of theta is 4 over 5. Notice that sine is directly correlated with so. The S relates with sine. The O is correlated with opposite, and the H is correlated with hypotenuse. Sine is opposite over hypotenuse. It goes from a left to right order. Let's find cosine of theta. What exactly is cosine? Cosine is adjacent over hypotenuse. What exactly does adjacent mean? In simple terms, adjacent just means next to, but when it comes to trig, adjacent means the side closest to the angle that's not the hypotenuse. So what's the side that's right next to theta that's not the hypotenuse? The side right next to theta that's not the hypotenuse is 3. So 3 is adjacent to theta. So this is 3 over the hypotenuse 5. So cosine of theta equals 3 over 5. Notice that similar to so, cosine is also correlated with ca. The C is related to cosine, the A is adjacent, and the hypotenuse is, the H is hypotenuse. Again, this is from a left to right order. Cosine is adjacent over hypotenuse. Let's solve for tangent of theta. What exactly is tangent? Try to figure this out on your own with TOA. Feel free to pause the video. Tangent is opposite over adjacent. Notice that similar to so and ca, TOA is also related with tangent. The T is tangent, the O is correlated with opposite, and the A is correlated with adjacent. Tangent is opposite over adjacent, again from a left to right order. Opposite of theta is 4. Adjacent to theta, or the side closest to theta, that's not the hypotenuse, is 3. So tangent of theta is 4 over 3. Now let's recap. Draw a right triangle to make better sense of this. So, or sine of theta is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse, and tangent of theta is opposite over adjacent. Notice we can use sohcahtoa to help us remember this. The S stands for sine, the O is opposite, and the H is hypotenuse. Sine is opposite over hypotenuse, a left to right order. Ca, the C stands for cosine, the A stands for adjacent, and the H stands for hypotenuse. Cosine is adjacent over hypotenuse, again from a left to right order. Toa, the T stands for tangent, the O stands for opposite, and the A stands for adjacent. Toa, tangent is opposite over adjacent, again from a left to right order. Now let's discuss the 3 remaining trigonometric functions. This is cosecant, this is secant, and this is cotangent. Cosecant can be rewritten as CSC, secant can be rewritten as SEC, and cotangent can be rewritten as COT. Now, what exactly are these functions? Cosecant of theta is the reciprocal of sine of theta, or 1 over sine of theta. Secant of theta is the reciprocal of cosine of theta, or 1 over cosine. Cotangent of theta is the reciprocal of tangent of theta, or 1 over tangent of theta. Now let's review what a reciprocal is. Find the reciprocal of A over B. By definition, the reciprocal is 1 divided by the fraction we're trying to find the reciprocal of. We have to make the denominator equal 1, so let's multiply the denominator by B over A, and then multiply the numerator by B over A. We can cancel out everything in the denominator. This will turn into 1, and the numerator will become B over A. And therefore, the reciprocal of A over B is B over A. Notice how we can just flip the numerator and the denominator to find the reciprocal instead of doing 1 divided by the fraction every single time. So let's do an example problem. This time, let's use the 5, 12, 13 right triangle. Recall that cosecant of theta is 1 over sine of theta. Secant of theta is 1 over cosine of theta. And cotangent of theta is 1 over tangent of theta. Let's find cosecant of theta. Recall sohcahtoa. Cosecant of theta is 1 over sine of theta. 1 over sine of theta is sine of theta is opposite over the hypotenuse. So that's 12 over 13. Let's cancel out the denominator. Let's make the denominator equal 1. We have to multiply both the numerator and the denominator. And we end up with 13 over 12. So cosecant of theta is 13 over 12. Notice that we can just find sine of theta which is opposite over hypotenuse, and we can flip the numerator and the denominator. So cosecant of theta is just 13 over 12. Now let's find secant of theta. So what is secant of theta? Try this problem on your own. Feel free to pause the video. Recall that secant of theta is just the reciprocal of cosine. So first, let's find cosine of theta. Cosine, if we look at SOHCAHTOA, is adjacent over hypotenuse. So that's equal to 5 over 13. Now, to find secant, we just have to find the reciprocal of cosine of theta. The reciprocal is when you flip the numerator and the denominator. So secant of theta is just 13 over 5. Now, you may have a picky teacher, so let's show our work. 1 over cosine of theta is 1 over 5 over 13. If we cancel out the denominator, and we do the same thing to the numerator, the outcome is the same. Secant of theta is 13 over 5. Let's find cotangent of theta. Recall that we just have to find the reciprocal of tangent of theta. Tangent, according to SOHCAHTOA, is opposite over adjacent. That would be 12 over 5. If we flip the numerator and the denominator, cotangent of theta is 5 over 12. So cotangent of theta is 5 over 12. That's our final answer. Before continuing, I'd like to mention that at this stage of your math education, it may be wiser to purchase a proper calculator because unfortunately Desmos isn't really allowed on tests, and you also need a calculator for trigonometric calculations. Schools typically push out the TI-84, but personally I'd recommend the Casio CG50 because it's a lot faster and a lot newer, plus the graphics are colored. It's just a lot nicer in my opinion. Here's a few practice problems for you to work on. Let's use a 7, 24, 25 right triangle for this problem. Solve for sine of theta, cosine of theta, tangent of theta, cosecant of theta, secant of theta, and cotangent of theta. Feel free to pause the video to work on these problems. Now, if you're still struggling with remembering what to do, I would suggest writing out SOHCAHTOA. Sine is opposite over hypotenuse. So sine of theta is the opposite side over hypotenuse, which would be 24 over 25. Cosine of theta is adjacent over hypotenuse, according to SOHCAHTOA. The adjacent side of theta is 7. The hypotenuse is 25. Tangent of theta is opposite over adjacent. Opposite of theta is 24. Adjacent to it is 7. So tangent is 24 over 7. Recall that cosecant of theta is 1 over sine theta. Secant of theta is 1 over cosine of theta. Cotangent of theta is 1 over tangent of theta. Cosecant of theta is the reciprocal of sine of theta. So we just need to flip the numerator and the denominator. So cosecant of theta is 25 over 24. The same rule applies to secant of theta. We just need to flip the numerator and the denominator. So that would be 25 over 7. Cotangent, we just need to flip tangent. So that would be 7 over 24. Now, how do we apply this trig knowledge to other math problems? Let's say we're given a right triangle. with angle theta and side B. Solve for side x. Feel free to try this problem on your own. Now, if we refer to SOHCAHTOA, sine is opposite over hypotenuse. So sine of theta is opposite, which is x. X is opposite of theta over the hypotenuse, b. Now, how can we solve for x? Let's multiply both sides by b. On the right side, b cancels out and turns into 1. So x ends up being b times sine theta. And that's your final answer. Now let's try this with a problem with actual numbers. Let's say we're given a right triangle with 53.15 degrees and a side of 6 and x. Solve for x. Feel free to pause this video to try this on your own. Now this problem's a little different. Let's go back to SOHCAHTOA. If we use sine, we're going to be using the opposite side over the hypotenuse. Unfortunately for us, the hypotenuse is missing, so we can't really do sine. Now let's try cosine. Cosine is adjacent over hypotenuse. We have an adjacent side length, but we don't have the hypotenuse, so we can't really use cosine. Now let's try tangent. Tangent is opposite over adjacent, which we're able to do. So let's use tangent. Tangent of 53.15 degrees is opposite, which is x, over adjacent, which is 6. Now let's isolate x. If we multiply both sides by 6, or 6 over 1, we can cancel the right side, and x will equal 6 times tangent of 53.15 degrees. Now this is the exact answer. However, if your teacher wants an approximate degree answer, what you want to do is pull out your calculator. Make sure to set your calculator to degree mode, because in radian mode it won't work. If you do 6 times tangent of 53.15 degrees, you get approximately 8. So that's our answer. Let's try one more problem. Say we're given a right triangle with 30 degrees and with an adjacent side of square root of 3, and we have to find x. Feel free to try this problem on your own. Now, let's see what we're missing. We're missing the opposite side. The side opposite to 30 degrees is missing. So we can cross out all of the trig functions that require an opposite side. So let's use cosine. Cosine of 30 degrees equals square root of 3, the adjacent side, over x, the hypotenuse. Now let's isolate x. Let's multiply both sides by x. This cancels out and turns into 1. Now we get x times cosine of 30 equals square root of 3. So then we can divide both sides by cosine of 30 degrees. X equals square root of 3 over cosine of 30. Now you can plug this value into your calculator. And you'll end up with the answer x equals 2. This is an exact answer. If you have a right triangle with 30 degrees, it's actually a special right triangle. This is the 30, 60 right triangle. Opposite of 30, the length is 1. Opposite of 60, the length is square root of 3, and the hypotenuse is 2. Now let's say we're given the same problem, and assuming you don't know what special triangles are, you're asked to solve for x with the secant function. Try this problem on your own. Now, if we use secant to solve it, it's going to be a little bit different. Secant of theta is 1 over cosine of theta. Cosine of theta is adjacent over hypotenuse. So this would end up being secant of 30 degrees equals 1 over square root of 3 over x. Recall that we can also just find the reciprocal. The reciprocal of square root of 3 over x is just x over square root of 3. So secant of 30 degrees equals x over square root of 3. If we multiply both sides by square root of 3, we end up with x equals square root of 3 times secant 30. Now to plug this into your calculator, do square root of 3 times 1 over cosine of 30 degrees. And you should end up with the same answer, x equals 2. That's our final answer. If you're confused as to why both of the solutions were the same, here's a closer side-by-side comparison of the two methods of solving the same problem. Feel free to pause the video if you want to take a closer look. Now, let's say we were coming up with a trig problem. Let's let sine of 15 degrees equal a. Now let's write out the problem. Sine of 15 degrees plus 30 degrees. Now what should we solve for first? Should we solve for sine of 15 degrees and then add the 30 degrees afterwards, which will be a plus 30 degrees? Or should we solve for 15 degrees plus 30 degrees first and then do sine of 45 degrees, because 15 plus 30 is 45. Now we need to specify what to solve for first. To specify that we want to solve for sine of 15 degrees first, we can write a parenthesis before and after the 15 degrees. Or we can write a parenthesis before the sine and after the 15 degrees. This will specify we want sine of 15 degrees solved before adding 30 degrees. To specify we want to solve for 15 plus 30 degrees first, we can write a parenthesis before the 15 degrees and after the 30 degrees. So we'll be solving for sine of 45 degrees because we're adding 15 and 30 first. So just note that parentheses and trig are very important. Now let's discuss inverse trig functions. This is a normal sine function. To make this an inverse function, we can draw this symbol between the sine and angle. This is commonly confused for power of -1. This is the inverse symbol and has nothing to do with powers. We can apply this rule to other trig functions as well. This is the inverse cosine function, and this is the inverse tangent function. We can also write inverse trig functions another way, by adding an arc in front of it. So inverse sine of theta can be written as arc sine of theta. Inverse cosine of theta can also be written as arc cosine of theta. Inverse tangent of theta can be written as arc tangent of theta. Keep in mind that it's up to you whether you want to use arc or the inverse symbol. Normally, calculators like to use the inverse symbol when it comes to buttons, but typically when we're doing word problems on paper, we like to use arc. But again, it's up to you. Arc is my personal preference, so this is what I'll be using throughout the video. Now let's discuss some basic identities that you should commit to memory. Arc sine of theta equals theta. arc cosine of theta is equal to theta. And arc tangent of theta equals theta. You should commit all three of these to memory. Now let's do an example problem. Let's say we were given a right triangle with the unknown angle theta and the sides 4 and 5. We know sine of theta is opposite over hypotenuse. So that's 4 over 5. Now, what if I asked you to solve for the angle theta? How can we do this? Recall one of the inverse theorems. Arc sine of theta is equal to theta. Since we know what sine of theta is equal to 4 over 5. We can replace sine of theta over here with 4 over 5. Arc sine of 4 over 5 is equal to theta. The simplest way to solve for arc sine of a value is with a calculator. On a calculator, there should be a button that looks remotely like this. Make sure your calculator is set to degree mode. Inverse sine of 4 over 5 is approximately 53.13. So theta is approximately 53.13 degrees. And that's our final answer. Let's work on a few more practice problems. Let's say we're given this right triangle with the legs 4 and 8. Feel free to solve for the angle theta on your own. Now, what's the most efficient way to solve for this problem? We can find the hypotenuse with the Pythagorean theorem, but that would be an extra step. The most efficient way to solve this would be to use tangent, because tangent only takes advantage of the opposite leg and the adjacent leg. Tangent of theta is 8 over 4. 8 over 4 is equal to 2. Now, recall the arctan theorem. Arctan of tangent of theta equals theta. Tangent of theta equals positive 2. So arctan of 2 equals theta. Now let's plug this into our calculators. Inverse tangent of positive 2, theta is approximately 63.43 degrees. So that's our answer. Now let's do one more practice problem. Feel free to pause this video to try this out on your own. Now, let's take advantage of cosine of theta, because cosine takes advantage of adjacent and the hypotenuse legs. Cosine of theta is 8 over 17. If we refer to the inverse cosine theorem, arc cosine of cosine of theta equals theta, let's replace cosine of theta with 8 over 17. So arc cosine of 8 over 17 equals theta. Now let's plug this into our calculators. Inverse cosine of 8 over 17. Theta is approximately 61.93 degrees. So this is your final answer. Thank you guys for watching this video. If you guys are interested in a unit circle video in the future, I'll be more than happy to make one. If you want to support me, you can subscribe and like the video.